Aerodynamics appears everywhere in our daily life. In this video, I'm going to explore the factors that influence aerodynamics when you're riding a bicycle. Here's the outline. First, I'll give a rough introduction of air resistance, and then second one is the influences of equipment. Last but not the least, I'll focus on posture. So here we go, air resistance. As you can see, the picture above shows how air goes through different shapes. When air goes through objects, it will cause turbulence. The more serious a turbulence is, the more drag force it produces. So, the objective is to let air move as smoothly as we can and minimize the force which turbulence brings to us. Let's take a look at this formula. Fd is the drag force, ρ is density of air, Cd is drag coefficient, A is the frontal area of cyclists on a bike, and V is the velocity. According to this formula, when the velocity increases 2 times, the drag will be 4 times bigger, which means you have to produce 4 times the power to get to that speed. As a result, reducing the air resistance is the thing we have to do if we want to be more efficient. The factors that affect air resistance can be divided into 2 categories. One is the equipment, and the other is the posture. Let's start with the bike itself. Wheel is the biggest factor that influences air resistance except for the body. It accounts for 9% of all the drag, so the shape of the wheel is imperative. Wheel can be divided into 3 parts: rim, tire, and spoke. There are numerous types of rim on the market, from lower than 25mm to over 15mm. While biking, air will go through the space between the center that is surrounded by spokes and rim. As a result, reducing that space is one of the answers to decrease the drag. Because of this, the higher the rim is, the more aerodynamic it gets. Since I mentioned that the wheel is the biggest factor that influences drag besides the body, changing the posture is the most efficient and cheapest way to reduce it. For the posture, there are uncountable postures for you to choose. For now, I merely introduce the posture that most road bike riders will choose when they are cycling, and the order will be less aerodynamic to more aerodynamic respectively. First one is called the hoods. The hoods is the most common posture you can observe on the roads, and the reasons are it is comfortable and easy for control, braking, shifting. This is also the posture I usually choose. Second one is the drops. The drops posture is similar to the hoods. Just move your hands down to the drops. This posture is more aerodynamic, but it's still comfortable while riding. Third one is arrow hoods. As you can tell from the name, arrow hoods is almost the same as a hood's posture. The only difference is arrow hoods has to lower your back and try to let your back become flat to minimize frontal area. Lastly, arrow bars. Arrow bars is common in individual time trials, which is ITT and triathlons. Next, there are some postures that are super aero but it's forbidden by the UCI due to safety. First is the super tuck. The super tuck is to put your hands on the drops and move your body onto the top tube. It looks weird but it's pretty fast. Second one is the poppy pulse. It is the same as the aero bars, but there are no aero bars on the handlebars. It's dangerous because the area that you contain the bike is pretty small, and it's tough to control while you are facing an emergency situation. In short, aerodynamics is not that far away from our daily life, and it's not only in bikes. If we can use it properly, it's able to solve some issues in daily basics, such as if you are renting a bike, you can choose a more aerodynamic one, and also, if cars can be designed more aerodynamically, it can reduce the consumption of the fuel. Thanks for your listening. See ya.